Hello, mic testing, 1, 2, 3. Reshooting the video because last time it did not capture my audio. Good evening, everyone. This is day one and video number one of solving the blind 75 list. You could check this out on Leetcode line 75. These are some of the most important and frequently asked DSA questions in interview. So I am going to provide all solutions to all of the questions within the next 75 days. So this is the day one. We are going to solve question number 217 on lead code. You can code along or watch the video for understanding. So let's go. What this question states? This question states, right, first. This question states that we are given an array 1, 2, 3, 1, and we need to check that if this array contains any duplicates. We need to check if any element of the array appears twice or more than that. So in this, we can clearly see 1 appears twice. In this test case, we can see none of the element appears twice. So it returns false. If an element returns more than once, we need to return true. So here in this test case, it returns true. So if we are going to check the constraints, first constraint is the length of the array can be up to 10 to the power 5. That means 10 10 to the power 5. So we can understand that for this code to be submitted online, our time complexity should be less than h square. So the first brute force solution I can come up with brute force is a simple nested for loop. Nested for loop in this case, for every element of the array, we will iterate to all of the rest elements and we need to check if there is any duplicates. So for sorry, for every element, iterate through complete the array and check if it is equal to our element. So for 1, it will check 2, 3, 1. So we can clearly see 1 appears twice, then return 2. And for worst case, worst is both arrays run n times. So the time complexity is O to power O of n square, which is even not so good. So we are going to try and optimize this solution. A better solution which I can come up with is first I will sort the array. What sorting will do is it will keep all the similar elements together. So it will sort this array into this array after sorting will be 1, 1, 2, 3. So we can clearly see all the duplicates will be together after sorting. So in sorted array, compare adjacent elements. So check nulls of I equal to nums of I plus 1. If this is true, then return true. Or at the end, we can return false. So we will go and try to code this up. For sorting, we can use inbuilt sort, that is sort nums dot begin. It by default sorts in the ascending order. You can also sort in the descending order. The code will still work as the logic remains same. That similar elements will be placed together. So first we'll sort this array. Num sort sort nums dot begin, nums dot end. So after sorting, we'll iterate through the loop or in the to 0 nums dot size I plus plus. So one thing which you need to keep in mind that we are comparing if nums of I equal to nums of I plus 1. So for every iteration we are comparing with the next element. So that this code does not make any error of uh, indexing. After one indexing we need to run up to I minus 1 as the last element will be already covered by I plus 1. If this is the case, then return true, or else at the end we can return false. We will try to run this code. The test cases are clear. We'll submit it. It runs. So we can clearly see. We know that time complexity for sorting is or sorting over n log n, and we are not using any extra space, so the space complexity will be over 1. That's it. And if I try to think of a better solution, I can choose some data structures. Data structures optimal solution. I can use a map or a set or a hashing. I can use any of these. I prefer to use a set. So I will create a unordered set, and in this set, what set does set does not store any records. So before storing any element in the set, I will check if it is already exists, and if it already exists, I will return true. Before storing, check if it already exists. If it does, return true. One more way to approach the solution is I will store all the elements into store. Second way, store all elements into the set and compare the length of set and nums. If in case there are no duplicates, then the length of nums should be equal to the length of set, as set does not store any duplicates. And if there were duplicates, the length of set would be less than compared to nums. So if equal, return false, else return true. So I can do any of this. I will go with checking if it already exists. I will remove this code and I will create a unordered set. What unordered set helps is the elements are not sorted in the set, so it uh, will it is more efficient in the time complexity. I will create a unordered set of and name it std, and I will iterate through nums or in I equal to 0. I is a nums dot size I plus plus. I will first check if std dot find takes over one time complexity, so that's not an issue. Nums of, and if that is not equal to nums of n, what this means is if it already exists, which means there is an index where nums of I is already stored in the set. Then I will return true. After that, I can, after outside the if statement, I can insert into the set stt dot insert nums of I. At the end, if this statement, if this condition was never true, that means this statement did not ever run. So then we can return false, as there were not any duplicates in the array. We'll try to run this code. What error does this use? Uh, yeah, I should try stt dot pen as we are comparing in the set. We clear the test cases. Submit the question. So that's it. That's the solution. Thank you. Here is the overview. Array, check duplicates, the brute force, the better solution, the optimal solution. And as we can see, insert and finding takes over 1. So the time would be only iterating this for loop once, iterating this for loop n times. So the time complexity will be O of n, which is a lot better compared to O of n log, but it will have an additional space of O of n, as we are using a set of size n. So that's the optimal solution. Thank you.